Good morning, students. This is Murlidhar, lecturer in chemistry. We are studying fourth A group elements and also called 14th group. Fourth A group elements: carbon, silicon, germanium, tin, lead. These five elements which are having general valence electronic configuration NS2, NP2. That means number of valence electrons are 4. That's why these elements placed under fourth A group in the long form of the periodic table. As you know, I already explained electronic configuration, oxidation states of fourth A group. Once again, I recapitulate. See, fourth A group elements, these are also called 14 group elements. The elements are carbon, silicon, germanium, tin, lead. Carbon, silicon, germanium, tin, lead. See, particularly the outer configuration of these elements are NH2, NP2. That means in a s orbital, two electrons are present. In p subshell, there are three orbitals, px, py. There is an empty period orbital. Actually, this is down state configuration. In excited state, what happens? These elements, whenever participating in excited state, one electron from s orbital promoted to pz orbital of same cell. So that elements can have four unpaired electrons in outermost orbits. That's why those elements can exhibit tetravalence. The maximum general valency of fourth A group elements all can exhibit tetravalence. Particularly the special element carbon, in every compound it has to show tetravalence. That means around the carbon we have four bonds. That thing you remember is very important in organic. For example, in ground state, all elements exhibit common oxidation state plus 2. When they are participating in excited state, four unpaired electrons are involved in bonding, exhibit plus 4 oxidation. So regarding oxidation state, I clearly explained under third A group. So regarding the major, the common oxidation state of fourth A group is plus 2 plus 4. Once again, I remind the important feature and properties of general common oxidation states. Regarding common oxidation state, lower oxidation state is plus 2, LOS. Higher oxidation state is plus 4. Here, being a chemist student, we have to remember three important characters when you go through the oxidation state of any group. Plus 2 oxidation states are ionic compounds. Majority of plus 2 compounds are ionic. Majority of plus 4 compounds are covalent in nature. The ionic nature gradually increases. Why? Because I told you the oxidation state of lower oxidation state down the group gradually increases. That means lead is stable in plus 2, it is unstable in phase. Come to carbon, it is stable in phase 4, but it is unstable in lower oxidation state, that is phase. And the lower oxidation state acting as reducing agents, majority of flexible compounds acting as oxidizing agents. Reducing character down the group increases, oxidizing character down the group decreases. That means from that what we can understand, lead compounds can act as better reducing agent. Regarding carbon compounds, they can act as oxidizing agent. Moreover, down the group metallic character increases. Whenever metallic character increases, if it is in case of oxides, acidic character also gradually decreases. That means oxides of carbon are acidic in nature, covalent in nature, but oxides of lead basic in nature, ionic in nature. So these are the important features you have to remember when you go through the oxidation state of any group. In every group, the trends will be like this. Okay. Actually, this is already explained in under third year also clear. Okay. In our syllabus, we are having chemical properties, chemical properties of fourth year group elements. Those properties mainly hydrates of fourth year group already we completed. Then second one, oxides. Third one, halides. Today our topic is halides. Today our topic is not halides. Today our topic is oxides. The second topic we are going to discuss. So our topic is oxides of fourth year. See, oxides of fourth year group we are studying. Mainly the fourth year group elements, these elements, fourth year group elements, fourth year group elements react with oxygen in pairs of air, in pairs of air at different temperature, at different temperature, to give two types of oxides, two types of oxides. See, the first type is monoxides. Monoxides, their formula is MO. MO. M means fifth, fourth year group element, carbon, silicon. For example, you can take carbon monoxide. In place of M, you put Si, silicon oxide. Like that, in last oxide, I'm going to write, for example, Pb, lead oxide, like that. Then second one, dioxides. Dioxide. They formula is MO2. MO2. Example, carbon dioxide, silicon dioxide, germanium dioxide, tin dioxide, etc. etc. See here, separation of dioxides is so simple because every element can directly react with oxygen. In presence of limited oxygen, they have to form monoxides. But in presence of excess oxygen, in presence of excess air, they have to form dioxide. But here important phenomena is regarding monoxides and dioxides. Dioxides are important. Dioxides, we have symbols of dioxides. For example, fourth year group element react with excess oxygen in presence of air gives M2 dioxide. For example, carbon on oxidation gives carbon dioxide. Silicon on oxidation gives silicon dioxide. Like that, we have germanium dioxide, tin dioxide, lead dioxide. So in these dioxides, the fourth year group element, every element is having place for oxidations. That thing you have to remember. By that we can understand some properties. When we know the oxidation state, we understood some properties. See here, properties of dioxides. See, particularly carbon dioxide gas at room temperature. At room temperature, silicon dioxide, not only silicon dioxide, other all dioxides are solids. This is the one first physical state regarding properties. Then second one, particularly you remember silicon dioxide is a solid, no doubt, but silicon dioxide is a giant molecule, just like polymer, giant molecule, giant molecule, chemically inert, chemically inert. That means silicon dioxide somewhat it is passive to the uh, chemicals. That's why it is chemically inert. Then third property, C, carbon dioxide, comma silicon dioxides are covalent compounds and acidic in nature. The remaining oxides, for example, germanium dioxide, tin dioxide, of course, lead dioxide. These are ionic and amphoteric oxides, amphoteric in nature. So, particularly regarding lead dioxide, come to lead dioxide. It is basic oxide. Actually, it is a metal oxide, basic in nature. Basic in nature. No, this is basic oxide. Remember. See here, fourth one. Whenever covalent becomes ionic, acidic becomes amphoteric and basic. That means down the group. In oxides, covalent and acidity decreases acidity decreases down the group down the group. Why? Because as metallic character increases. As metallic character increases. Number of times I told you this point. Metallic character increases. So simply remember non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. So the general statement I give you here, non-metallic oxides like carbon dioxide, silicon dioxide dissolves or dissolve in water, gave corresponding acids, corresponding acids, corresponding their acids. Students, all those are very significant and important points. Please you copy down, write down. See, for example, I am writing here carbon dioxide dissolved in water gives H2CO3. This is called carbonic acid. Carbonic acid. Like that, silicon dioxide, when it reacts with water, gives silicic acid. Okay. Then you write this reaction. So just now I said, what is that? Carbon dioxide, silicon dioxide. Those are acidic in nature. So carbon dioxide is acidic, silicon dioxide is acidic. So reacts with bases like sodium hydroxide to form sodium carbonate Na2CO3. Here Na2SiO3. This is sodium carbonate. This is sodium silicate. Then byproduct is water. So being acidic reacts with bases to form salts. This is base, acid gives rise to salt and water. Nothing but neutralization reaction. You might have well known, you have studied under you have studied from ninth standard onwards, the school level equation. Okay. Then just now I tell you, stannous oxide, germanium oxide, dioxides are amphoteric in nature. That means they can react. For example, let us take stannous oxide. This is amphoteric in nature. Amphoteric. Amphoteric means all of you can know. Amphoteric means having both acidic property and basic property. That's why it reacts with if it is having it is having basic nature, so it reacts with acid like HCl, forms what happens stannic chloride SnCl4 plus resultant compound is H2O. For balancing sake, here we put 4HCl, 2H2O. The same dioxide reacts with base. Here it forms sodium stannate Na2SnO3 plus H2O. Plus H2. Na2 means here 2. Na2 SnO3 plus H2O. For balancing check here also you put 2, 2. So when you have clear idea about the concept, you don't bother about the balancing. It is very easy to balance. And of course, in your intermediate 10 plus 1 level, in first year level, you have stoichiometric topic. That is completely balancing chemistry. There you learn how to balance the equations. So that here, when you want to study higher topics, no question of balancing. Particularly in organic chemistry, we bother about how the reactants react and what are the products we are getting. That is only the important thing. No need to balance. Okay, these things you have to write down, students. Especially when the matter comes about uh, carbon monoxide. This is carbon dioxide, all of you can know. Carbon monoxide. I am telling you carbon monoxide. Neutral in nature. Carbon monoxide is a neutral oxide. Neutral oxide. It donates electron pair to the metal so that it behaves as ligand. It acts as ligand. Ligand when react with metal to give complexes. To give complexes. What are those complexes? For example, nickel reacts with carbon monoxide at 200 degrees Celsius temperature. You are getting complex like this: nickel tetracarbonate. Moreover, these are stable complexes. Like this, iron reacts with carbon monoxide. You are getting iron pentacarbonate. All these are metal complexes, coordination compounds. Okay, here no necessity to discuss in detail, but particularly entire note sheet will be useful. The students who are preparing entrances like NEET, JEE mains, see the mixture of carbon monoxide plus H2 is water gas. Remember this. Carbon monoxide plus N2 is producer gas. Producer gas. Producer gas. So regarding this, I tell you some more about dioxides. For example, carbon dioxide when it is when when it is in solid is called dry ice. Is called dry ice. So carbon dioxide solid directly change to gas. So here what happens? The process of conversion of dry ice into gas, carbon dioxide gas. This process we call as sublimation. Sublimation. You have to remember. Okay. So this is enough information about the oxides of fourth group. Particularly, we have to concentrate on carbon silicon. The first two elements in any group important. Their chemistry important, elemental chemistry important, chemical reactions of those elements important, and chemistry of their compounds also important. That we will discuss in next class. Stop here. Uh, the students who can watch the video, please subscribe, share to the others. Thank you. Thank you, one and all.